Good morning, everyone. Welcome for the Voltha TST meeting for August 18th. Just a quick reminder that this meeting is recorded and will be published on YouTube, so be mindful of what you hear. We only have two topics on the agenda for today. The first one is from Girish that want to discuss some changes he's making in the OpenMPI adapter. And then we have, I think, a quick presentation from Ken or a discussion on the migration between Kafka to RPC for the inter-container messages. So Girish, do you want to share a document? Or you can give you
yeah,
right.
go ahead, Tio. I want to share a document.
You should be able to see.
Just a minute. I'm having some issues. Just give me a minute. I'm having some issues sharing my screen.
Are you from the application or from the browser?
No, from the application. Just a minute. Oh, it says Zoom will not be able to record the contents of your screen until it is quit. So probably I'll have to quit and come back again.
Yeah,
Just give me a
no problem. Yeah.
I'm back. Sorry for the trouble.
No worries. Okay, yeah, we can see your screen.
Okay. Yeah, some initial hiccups there. Okay, let me dive into this document now. So as per the last scalability brigade call, so it was discussed that, Tio was seeing issues with flow ads where the adapter would sometimes take more than 10 seconds to respond to flow ads. So we discussed some optimization schemes in the OpenOLT adapter that could possibly, get us out of this problem. So one was, to create a flow manager per PON port because we had some global locks across the entire OLT device, and we could limit that lock to the PON port if we, created a flow manager per PON port. Most of the PON resources like the ONU ID, jump port ID, alloc ID, with the exception of flow ID, are PON resources that are, just unique across the PON port. So, having the locks, and these locks are actually around resource management. So we could actually, gain a lot by having flow manager per PON port, and these locks per PON port could give us some performance improvement. And there was also another optimization that we discussed was to move this flow ID to the OpenOLT management of this flow ID to the OpenOLT agent, or reserve a pool of flow IDs per ONU. So these are the two optimization schemes that we discussed. So the first thing was to create the flow manager POM port. So this is actually done and is already working, but we haven't got to a chance to actually try this out at scale. I think Tio would be trying that today. So the another option was to move the management of flow ID to the OpenOLT agent itself. So this is something I have a proposal in mind, and I wanted to share with the community and get your feedback on this one. So before I do that, I just want to share with you the current behavior, and then share my proposal and go over that and see if really need to do that. So what happens is when OpenOLT adapter receives a flow from the core, assume that it doesn't have any p-bit classifier. So the OpenOLT adapter would actually replicate this flow across all the gem ports. So let's assume that you have a 1T con 4G 4 gem port model. So let's assume that 0 2 p bits are used by 1024, 134 by 1025, p bit 5 by 1026, and p bit 67 by 1027. So if the flow does not carry a p bit, this flow is replicated across these 4 gem ports with an additional classifier of these p bits. Because in theory, you could receive a packet with any of these p bits and you should still be able to process that. And especially on the BAL, since OpenOLT adapter is in the open source, it actually works with Broadcom BAL. I mean, it works with OpenOLT agent, but OpenOLT agent is actually working with Broadcom BAL as of today. The Broadcom BAL flow would actually require a gem port classifier as well. So when you install the flow, you will have to say, this flow, it caters to which particular gem port. And in theory, you could have, packets landing on any particular gem port. You have to have the classifier of the p bit as well as the gem port in the flow. So although ONOS is sending a single flow, you have to replicate it across all the p bits with specific gem port classifier so that you are able to cater to that particular packet coming from that particular gem port. So you do all this processing 8 times, once per particular p bit. So the first thing you do is to derive OpenOLT proto flow message from the read-write core flow classifier and action. So this is nothing but actually a open flow message. And this is the OpenOLT proto flow message. I mean, these are not one and the same, but the OpenOLT flow proto flow is actually derived from the read-write core flow classifiers and actions. So whatever is the classifier and action, you also add an additional p-bit classifier, as I discussed before. And then you basically generate a flow cookie, which is basically a hash of the OpenOLT proto flow message. So you first look up this flow cookie on the database, and if you find this flow cookie on the database, I mean, you assume that this flow is already installed on the device, so nothing to just return. So otherwise, you proceed to next steps. So the first thing you do is to request for a flow ID. So this flow ID is not the flow ID that is coming from read-write core flow message. So this flow ID is the BAL flow ID. And so the flow ID coming from read-write core is actually of 64-bit size. But this flow ID is of, the max size is 16 bits, 65536. So you generate a unique flow ID. You just basically request the Pond resource manager and it allocates a unique flow ID for you. And now you go ahead and install this flow on the device. So on successful install, you basically back up this entire OpenOLT flow proto flow message on the KV store. So I mean, if this flow fails to add, you just free up this flow ID back to the pond resource manager. So assuming that it's a success, you back up this flow on the KV store, and you also store some additional data on how many flow IDs are mapping to a particular jump port. So this is basically useful when the flow is deleted and no flow is actually referencing a particular jump port. You basically go ahead and free up the jump port to the pond resource manager, and you also clean up this jump port on the ONU device. So this particular mapping is useful for us. And you also store the list of flow IDs for a given subscriber. So all this is actually backed up on the KV store. So once the device is actually deleted, you go ahead and free up all these flow IDs back to the pond resource manager. So all this processing is done for one flow, and this is done 8 times. I mean, if the flow does not carry a p-bit classifier.
So you don't pre-out when you talk to the pond resource manager, you don't say, hey, I know I'm going to do this 8 times, so give me 8 IDs. Instead, you're repeating the process with all the locks one time. It's one flow ID per request, as opposed to kind of a bulk request.
We don't do that at this time, but I think that's an optimization. I mean, if we continue to retain this approach, I think that's an optimization I can work on. I mean, I have to check, but as far as I know, we request only once. I think that's a fair point. I think that's a fair optimization that we could do. I'll make a note of it. Yeah, but to answer your question, I don't think we do that at this time.
Okay.
Any other questions so far on the current approach? Okay, so let me move to the proposed change. So in a strict sense, as per the ITU pond standard, I don't see a mention of any mention of flow ID anywhere. I mean, the only pond resource IDs that we really talk about in the standards are, the ONU ID, jump port ID, and alloc ID. So flow ID is something that we introduced because it was mostly an influence from the Broadcom BAL, because we also needed, there is also a mention of flow ID on the Broadcom BAL, and somehow that crept in to our OpenOLT adapter implementations. But otherwise, in a strict sense, the only pond resource IDs that I have encountered or seen is ONU ID, jump port ID, and alloc ID. And since we could actually push down the management of flow ID down to the OpenOLT agent, and let all this management of flow ID be abstracted from the OpenOLT adapter. So that's the core idea behind this proposed change. So also another idea is to use the flow ID that is coming from the read-write core and have the adapter just deal with the single flow and let the agent do any replication needed. And let the agent generate its own flow ID as necessary by its underlying platform. So that's the core idea here. So to go in a little more detail, so the adapter would receive a flow from the read-write core. So it generates an OpenOLT proto flow message from that. And it should also pass some additional information in the flow proto message. So basically it says which particular p-bits would...
Hey, Girish, just a couple of comments on
Hi, Sean.
pushing everything down to the OT. So there are a couple of scenarios where that could be, may not be advantageous, right? One is type B protection, where you're protecting pond ports with another pond port. In that case, all the TC layer attributes need to be identical. And another one is ngpond2. Obviously, that's not in the picture right now, but in that case, between OLTs, those TC layer attributes have to be identical as well. So if by pushing them down to the OLT, we have to have some way of, I guess, accessing those and sharing that information across OLTs potentially.
The flow ID that BAL requires is not a TC layer attribute, right? Across.
Oh yeah, flow ID we don't care about. It's
Right.
just the TC
Everything
layer.
else,
Yeah.
Everything else is still managed by the OpenOLT adapter. So even in NG.2 or Type B protection, you should still be able to use, the OpenOLT adapter should still be able to assign the same attributes to across OLTs or across PON ports.
Yeah, the ONU ID, jump port ID, alloc ID still remains at the adapter.
Oh, sorry. I thought that was getting pushed down to the agent. Sorry, I misunderstood. Sorry.
Yeah, only the flow ID management is pushed down to.
Sure, no problem.
This is why. Hi. As far as I understand, if, for example, you want to delete an flow in the agent, then the parameters to find the correct flow is the ONU ID, Genport ID, and Tcon ID, not the flow ID that the OpenOLT send. Adapter ID.
The adapter also needs to send the flow ID. Currently.
Flow ID. I mean, if agents use this flow ID, then it should take some, keep some maps between these flow IDs.
Yeah, of course. Yeah, the agent has to maintain a map of which particular Voltha flow ID, basically the flow ID that is coming on the OpenOLT proto message, translates to the underlying platform's flow ID. Yeah, it has to map that.
Okay, and this is a big problem because it should persist this also.
Not necessary. The agent need not persist because on agent on OpenOLT reboots, things are always treated as repush everything as of today. OpenOLT agent need not persist anything.
Okay, in case of the agent restart, this is also the case?
Right now, also when agent crashes, it is treated as an OLT reboot.
Okay.
So nothing really changes on that aspect.
Is that our eventual goal though, or is our eventual goal not to treat those events as reboots?
So for that matter, right now, OLT does not persist anything. So we have not made a decision, especially on the OLT device, a particular process crashes, is that treated as, the entire OLT reboot? To me, as of today, any process crashes on the OLT. Let me not say any process. So there are only two processes on the OLT, H-core ASFE OLT as of today. One is the BAL process and another is the agent process. So any of these process crashes, we cannot recover. Both these processes has to be restarted again. So it is as good as OLT reboot.
That means if the agent crashes and we treat it as an OLT reboot, we have a data path disruption.
Yes, you're right.
Where we really don't need to have that disruption.
Well, we don't need that, but it's not easy. So for example, if the agent crashes and it comes back and you don't want data path disruption, then you need to persist all the configuration that you have done on the BAL. And then, reconcile all of that information and then, continue with what you're doing earlier. We don't have resiliency.
Be able to read it back from the BAL so that we can reconstruct it. We don't necessarily have to persist it. It's already there. We have to access it and reconstruct it.
BAL does not have that mechanism to reconcile all that information that was done on BAL. Okay. So it's not that easy to do. It's not possible as far as I know. There is no single API that would you could just invoke and it gives you back all the current running configuration on the BAL and you could just reconcile that. No, that's not possible today.
Okay.
I mean, there are bits and pieces. You could query all the gem ports, you could query all the alloc IDs, you could query all the flow IDs, you could query the schedulers. But there is no single API that would, give the running configuration on the device.
Right. I understood. The question is the complexity of actually querying the information via multiple API calls. Is that worth not disrupting the data path? And I don't know how processing intensive that would be or time consuming either.
Yeah, it's certainly possible, but we have not analyzed
and also
it's probably not worth the while.
Somewhat orthogonal decision to what we were discussing over here, in some ways, right?
In some ways, but not if going this route locks us into not being able to do that later. And I think that was what the previous question was getting at, if I understood it correctly. That if we do this and we don't have a mechanism to reconcile or persist this information at the OLT, then we are, from this day forward, assuming any process crash is an OLT reboot.
Sure. It's not dissimilar to what we have, the situation we have today also. Any process crash, like Girish was saying, is still similar to a reboot.
Again, agreed. Just the question is that the direction long-term we want to continue? Yeah, because it seems to me that we might make some decisions here differently depending what our long-term goals around that are.
I have not heard anything from the operators on this aspect. Does Maher or anyone from TT have any thoughts on this?
This is some kind of detailed thing that we can get from the operators, but beyond the operators, we may require something from the product. If you plan to use this product as a product of this your company, then we also should expect something from the product.
Mm-hmm.
Yeah, I agree.
So, well, there are two different flows here and flow IDs here, and we don't have maps between them in anywhere. So this seems a bit tricky, a bit problematic to me in case of the things that happened, the things that David mentioned happened. So I cannot exactly say that in this case, this will be a problem in the future, but it seems a bit problematic to me.
But surely the agent will retain a map, right? For the flow ID that is coming from the adapter to the actual BAL flow IDs that it puts in, right?
But to an unpersistent map.
Yeah, but for that matter, agent already maintains some other maps. For example, the TM scheduler IDs, queue IDs. So these are, BAL specific resources. These are not really exposed to the OpenOLT adapter. We don't cache them or persist them. We cache them, so we don't persist them as of today. So we are already there. I mean, we are already in that problem that you are describing. So if agent were to crash and come back again, I mean, it has lost all this information. So we should start, I mean, if this is really a requirement, then I think we should start building some persistence on the agent. That is another topic altogether.
Yeah, that is, and I would actually resist putting persistence on the agent more towards reconstruction or reconciliation of data from lower level API calls, to be honest. I think one of the strongest arguments that I've heard today about this approach, though, is the flow ID not being part of the standard. It's a BAL specific thing, and therefore it doesn't really belong in the upper layers. And I think that's a strong argument to say, well, if it's really that device specific, it belongs closer to the device.
Yeah.
Yeah, I agree with that idea. Yeah.
Well, I mean, it brings back the problem that you said with, this information not being persistent, but we could, come back to that in another meeting, but I don't have an answer to that at this moment.
Yeah, I think the answer, if we need to, over a process crash, the agent crash, be able to reconcile or not cause data path disruption, then I think we will have to look at either being able to reconcile from lower level API calls or some level of persistence. The issue with, and again, that's a tougher call, so I won't actually go into it, but I think there are potential mechanisms we can use to get around that or solve that issue.
Yes. There are a couple of approaches that I need to think over, but yeah, we don't have that as of today.
Okay then.
Okay, should I go over this now? Okay, so
Yeah, I think.
okay. So first thing we do is to create OpenILT proto flow message from the read-write core flow classifiers and action, and you pass additional information for pbit to gemport map in the OpenILT proto flow message. And the second step is quite similar to earlier. So it generates a flow cookie, which is basically a hash of the OpenILT proto flow message. So if this cookie is already on the DB, we have basically installed the flow already on the device, nothing to do. Else, proceed to next step. So what happened next? Yeah, so once the flow is successfully installed on the device, you basically back up this flow on the KV store. So this is useful basically to if the flow were to come back again, you basically have this is useful to look up the flow on the KV store and not install the flow again.
So that flow there is included, that flow ID, or is it just the low level, the Broadcom flow ID, or is that?
The OpenILT adapter is not even aware of the
Okay.
Broadcom flow ID. It is just the flow ID that is coming from the read-write core.
Okay.
And you also store which particular flow ID mapped to which particular gemport, and this flow ID is the read-write core flow ID, not the BAL flow ID, as well as the list of flow IDs that are mapped to a particular subscriber. So all this is useful basically when you start doing some cleanup. So other than that, it finds no other use. So there are some.
One question, Girish.
Mm-hmm.
This RW core ID, it's not going to map to a specific gemport, right? Because once it goes to the agent and the agent applies the p-bits, then different p-bit-based flow IDs are going to map to different gemports. So are you basically saying that the RW core flow ID is going to be mapped to a collection of gemports?
It's actually a collection of gemports. So you have two different data path flows, say in the downstream.
Yeah.
And you basically have these two, and these two flows does not carry a p-bit. So you have basically two flows that are mapping to all the gemports. So you basically don't free up the gemport as soon as the first data path flow is cleared. Both these data path flows need to clear before you free up the gemport.
Got it.
So it's actually works like a reference count. You basically keep a reference count of how many flows refer to a particular gemport. And once all these flow IDs are cleared, the reference count becomes 0 and you free up this gemport. So there are some clear advantages here. So you're not replicating the flow across all the p-bits and let agent take care of that. And you also move the management of flow ID completely under the purview of the agent. And now you don't have a pawn resource that is device-wide, and you don't need to have device-wide locks. So this should give significant performance improvement from what we are seeing right now. So yeah, so that is it. So one thing to note is this: once this change comes in, so basically you will have some changes on the agent, and you will have some changes on the adapter. So the adapter would no longer be backward compatible, and the same applies to the agent as well. So you need to upgrade both the agent and the adapter. So this is something that should, I mean, if this changes is approved and implemented, this is something to keep note of.
Does that mean we need to go to a 3.0 release and not a 2.5 release? I mean, that's a administrative issue, but it is I think that's calls for a major release update.
Yes, yes, you're right. We need to make a separate major release for OpenOLT adapter and agent, but I think these changes are also coming in time for 2.5 release. So I think the code freeze is happening, September 10th?
Yeah, I understood. It is an administrative issue. It's not a technical issue. It's just more for Saurabh. I think if we're making a non-backward compatible change, that is a major upgrade to the version. We can't really release this under 2.x.
Hi, Girish, I have one question.
You're talking about Voltha release 2.5 being changed to 3. something?
We'll have to. I think that we can take this offline, but something needs to change a major release version so that we know that there's some incompatibility between the previous and the next. It has to be at least the adapter and the agent.
Yeah, at least the adapter and the agent. I agree. But we can talk about it offline.
Just something to put on the agenda for another time.
Sure. Somebody was asking.
Hi, Girish. This is Amit. Yeah, I had a question. So, just correct my understanding. So the problem is because we are taking a OLT wide lock at the adapter, right? But once you move the management of the flow IDs to the agent, we would have to take a OLT wide lock at the agent as well, right?
Yes, you're absolutely right. But agent as of today is not doing much processing. It's mostly a conduit between the OpenOLT adapter and the BAL, while adapter is doing a lot of processing. And so the agent could take a bit more load. So it should not cause any significant problem there. And agent code is also written in C++, so it's a compiled language, unlike Python or.
Is it single-threaded? The agent.
So agent is the gRPC calls are actually invoked on separate. So agent is actually a server, gRPC server, and each API call is actually pushed into its own thread. So it's actually multi-threaded.
Okay.
So agent basically does not do anything on its own. It receives the call from the adapter, and each gRPC API call is actually pushed into its own thread. Yeah. So Amit, does that answer your question?
Yeah,
it does.
So, yes, I'm just thinking about it. So basically, see, conceptually, the locking would still be there, right? It's just that because
you're right.
Because you might not have to go to persistent DB, like we're going to HCD by grabbing the lock. So that would help, right? Because right now you're holding the lock for a much longer time.
Yes.
There in the agent, because you're not going to go anywhere, it's just in the memory. So critical section would be much lesser, and the time for which you hold the lock would be lesser. I think that is the idea, right? That minimizing that, we will be able to speed up things.
Yes, and also the adapter is doing a lot of read write to HCD, doing a lot of persistence. So that is also taking a lot of CPU cycles, and agent does not do any such thing as of today. And
that can be overcome by using more goroutines, right? So like, because we have a lot of we are supposed to have a lot of cores on the servers. So anyways, I think I get the idea. Yeah, thanks.
Well, there is another approach that I didn't discuss in this document. There was another idea that came in the last scalability brigade call, was to pre-allocate flow IDs to each subscriber. And we basically, that should also solve the problem. We don't have to go down this approach, but that removes a lot of flexibility that we have as of today. So I really didn't explore much on that, but is that something that we would want to go down that path?
That would again be embedding kind of device specific or BAL specific information in the adapter, wouldn't it?
Yes, so you basically have to know what are the flow ID ranges of the BAL, but the the adapter actually knows that already. So the first thing that the adapter does as soon as it makes contact with the device is to query its resource ranges. So it asks it to give back its jump port ID range, alloc ID range, flow ID range. So the adapter is actually device aware in terms of the resource ID ranges. So it could then partition this resource pool equally among all the subscribers. So the adapter has to be aware of the maximum number of ONUs that it's going to support on a given OLT, and then it could equally partition these resource pools across all the subscribers.
But even then, we're still at the adapter layer, the open OLT adapter layer. We're managing this flow ID resource, which is really very specific to a certain endpoint.
Yeah, I mean, yeah.
And so when we end up working with a device that's not BAL focused, would we still be passing down flow IDs even though they're basically ignored at the endpoint?
Yeah, you're right. Yeah, I mean that's another argument. Okay, so is this proposal okay? I mean, is this okay? I mean, if I go ahead and implement this, I did hear a few concerns regarding persistence, but that is something that exists. That issue exists already today. I mean, we could address that particular problem as part of another major work, but that's something that exists today.
I think it makes sense.
Thanks, David. Thanks, everyone.
Yeah,
So,
makes sense to me too.
Was there any proof of concept trial on this?
Yeah, we have proof of concept as in, so the first part is already tested, moving the flow manager per PON port is already tested and is working on hardware. All the hardware and functional tests are working. But I don't think there needs to be any proof of concept for the second part where I was saying that, move the flow ID management down to the OpenOLT agent. So all that matters for the BAL is that you provide a unique flow ID for every flow, and it does not matter where you manage this flow ID from, whether you manage it at the adapter or you manage at the agent. It shouldn't really matter. I don't think it requires any proof of concept.
Yeah, my point was not like it needs to. I just wanted to see if you have done some proof of concept to see like the gains in performance that you were mentioning about.
Well, no, the thing is, even to do the proof of concept, there is significant work involved. I mean, I might as well just, do that and, see what happens. It's about, 2 to 3 days of work.
Oh, okay.
And so if it doesn't make sense, I might as well just remove that and, go down another path.
So the thing is to do, if you make the changes in the OpenOLT adapter, you'll have to make the changes in the OpenOLT agent as well.
Yes.
But to try this out at scale, you're going to use BAL and you're going to use BBSIM, and BBSIM won't be doing it could do the flow replication, but the point is that it doesn't actually do data plane stuff.
Yeah.
Right? So you're only going to have the OpenOLT adapter changes in the BBSIM based environment. And that will definitely show you improvement because it's only doing whatever, 1/8 of the work, say.
Yeah.
So how do we
Yeah.
determine if we're actually seeing improvement on real hardware then?
That I don't know.
So what was the question?
How do we determine that this change actually shows real improvement on hardware?
Oh, ONF does not have so many ONUs.
But we do have scale testing for the OpenOLT agent. But it's a different kind of scale test. That scale test tries to see if it can handle all the resources that's being asked for.
Can we get a performance test with 1 or 2 physical devices and even see if we're seeing improvement with 1 or 2 devices?
I don't think it'll be visible with 1 or 2 devices. I mean, you might see, fraction of seconds or a few seconds of improvement, but that doesn't say anything. I mean, I don't think it's possible with 1 or 2 devices.
Even if we're doing performance monitoring down at the device level, at the agent level?
Performance no, I think we should really be monitoring the adapter, not really the agent.
We've got, well, again, as Saraf pointed out, we're obviously going to see improvements in the adapter. We're removing a global lock, and we're not we're removing repetition of code, for each pbit. So there's no doubt there's an improvement there. But we're shifting that workload over or down to the agent. So, we need to be able to determine if it actually has a change, else we may do this and we're still in the same boat. All we've done is kick the can to a different place.
Well, there exists an application already today. It's the scale tester. I might, pull it here. So this is actually an application that is used to test the scale limits of OpenOLT agent plus BAL or any other underlying platform for that matter. But the goal of this application was not really to test the performance, but only to test the scale. I mean, if we are
scale limit,
scale limits. So basically, if you configure, if you in the configuration you say that I want to support 512 subscribers, and fire this application, it would start configuring so many resources for a particular workflow, and you would know whether you're able to support so many subscribers for a particular workflow. But it doesn't really do performance measurement. It does only scale limit measurements. We could enhance this application to figure out pull out some metrics for the performance, and but yeah, there exists no application as of today that could monitor or pull out such metrics.
I kind of think we're going to need to do that. I mean, if we can't measure the improvement, we're guessing.
All right, let me take that action as well. But I don't think it's going to happen in this release. That's something that we have to push for next release. So
well, yeah, I get that. I mean, again, I think the change makes logical sense. I like the idea that if it's a BAL resource, it shouldn't be managed in the OpenOLT. But if we can't test it in this release and show that we get an improvement, I'm not sure we should be putting it in this release.
Yeah, fair enough. But who is testing who is testing so many ONUs on the real OLT device right now? I mean,
but if you use that argument, you could say, well, we're good enough for the way we are currently to keep that same number of ONUs. Right? We need some way to characterize the change.
Well, it's an improvement. It's an improvement for the Volta stack, undoubtedly.
Only if you don't consider the agent part of the Volta stack.
Yes.
We don't. Do we have any figures on the Open OLT agent in a testing environment? Like, how we never run anything at scale with it?
So we have run this, right? And basically what this tells you that if you're trying to do 1,000 subscribers and 1,000 subscribers has requirement for this many gem ports, TCONs, whatever, right? If we do this, then does BAL throw up at some point? And we have in fact found that, so in one particular case, the Turk Telecom workflow, BAL did not expose enough resources on the OLT. So if you went to 1,000 subscribers, it would stop working and start throwing errors. Then Broadcom made a change. So it's testing the scale limit for the number of things that you can configure. But like Girish was saying, it's not testing performance. It's not testing how fast it's doing it, right? So that's just something we haven't done. And
but is it enough? Like, will that tool test enough to tell us that the changes that Girish has proposed will not have any adverse impact on the OLT system?
oh, yeah, certainly we could use this application to test it's not impacting, the scale limits. But I don't think my change would break scale limits, but we could certainly test it. I think the point that David was making was, does it impact performance? Well, certainly, I mean, OpenOLT agent would do more processing, but on an end-to-end, well, there is certainly no way to prove this. I mean, right now, the issue that we are trying to address was the adapter was taking more than 10 seconds to respond to a flow add. With this change, if agent starts doing more processing on a real hardware with 512 subscribers, does it still take 10 seconds? I mean, there is no way to prove that.
Well, again, it seems to me what we'd have to do is take this test code, modify it or whatever to make sure it's to see modify it so it can produce performance information from the agent side or overall side. And then we could test as we have the code today, i.e. with everything managed in the OpenOLT agent. And we get a performance number by that. Then you make the change to push all that information, all that processing down to the agent, rerun this test, and see if we see a overall performance improvement. If we see zero delta between the changes, then we need to look for a different approach. If we see a marked improvement, then we say, hey, yep, this was absolutely the right thing to do. The agent can handle the additional workload. We've reduced the work on the OpenOLT agent. We're good to go.
Okay. Fair enough. Yeah, so let me just summarize the discussion here. Where was the document? So the first part of the change was pretty simple. I mean, it was hardly a few hours of work. So this is done, and let this merge. For the next part, before I do any change on the adapter, that is, yeah. So the first part is actually backward compatible. I mean, there is no issue with that. The second part would actually break backward compatibility, and we really don't know if it gives significant performance improvement for all this change that we are doing. So the first thing that I would do is enhance this a bit to pull out some performance metrics, get the current performance numbers, do the change on the agent, and run this test again. And if it's not significantly impacting the performance on the agent, OpenOLT agent, then I'll go ahead and do changes on the adapter. Is that fair enough?
If again, we're trying to look at the overall performance numbers. So the modification, and maybe you meant this and I just misunderstood. So you do the test as it is today, then you kind of make the change on the agent, but you were saying not change the OLT adapter?
Not change the OpenOLT adapter. Well, that would immediately follow if it certainly gives performance improvement on the adapter. There is no doubt about that,
Right.
because you're doing 1/8 of the processing, plus removing some redundant KV storage.
Okay, so by doing it just on the agent, you're saying, okay, let me run the test. My
Yes.
overall performance will actually decrease because now I'm doing the work both places. But I can look at the agent and see if it's had just significant impact on the agent.
So David, they are just tested independently, right? The adapter is tested with VBSIM. The agent is tested with the scale tester.
Yeah.
So you're not going to see something altogether, right?
Okay, I misunderstood how this test was working then. Okay.
Yeah,
This is
scale test.
independent of Volta. The scale tester is a completely different application that runs on top of the agent and makes the same gRPC calls that the adapter does.
Yeah.
Okay.
It's just
I thought it was
wraparound.
end-to-end.
No, it's not end-to-end.
Okay. All right, then that makes sense, I think.
Okay. Okay, then. So let me go down this path then first before I do any change end-to-end. I'll send a summary after this call. I have nothing more to present. Any more questions? Okay, I'm done.
Thanks, Girish.
Thanks, Girish.
So we actually took almost the entire call on this first topic. So we might have to bump the Kafka to gRPC discussion to a future call.
Yeah, I think it will take more than 5 minutes
to
go over that one.
That will probably take another hour.
It'll probably
possibly.
take another hour,
yeah.
But
possibly.
it's all right because we weren't targeting this anyway for the next release. So, and we already have something lined up for next week.
Yeah, next week is pretty busy, so I can move the Kafka to gRPC to the first week of September.
Yeah, sure, no problem. In the meantime, anybody, please take a look at the document because maybe a lot of things that we can resolve just by looking at comments on the document.
02, but I'll double check. I think you sent the document. I saw the document on the mailing list, so
yeah. There's already some comments already. It just need to more people look at it. That would be good.
Yeah, I'll add the link to the document here in the agenda, so it's easy for everyone to find it.
Yeah, thanks, Dave.
Okay, I think this was all for today. We'll talk to everyone next week for the Elasticstack showcase and the investigation of gRPC.
Just a quick reminder to everyone, September 10th is Code Freeze date. So please keep that in mind. That's about, 3 weeks away? So
okay, is there anything else that we need to discuss today? If not, thanks everyone, and have a good rest of your day.
Thank you.
Thank you.
Thanks.
Bye.
Thanks. Bye.
Thank you. Bye.